let's continue from where we were. We were playing with statements, which are little sentences which are either true or false. And what we're going to talk about now is how we can combine them together to do things to those statements to make bigger, more interesting statements. And we're going to do that using 3 operations, namely and, or, and not. And let's start with the simplest, namely not. Okay? So the negation of a statement is taking an original statement, say P, and forming a new statement with the opposite truth value. So it is not the case that P. So for example, the statement, it is Tuesday, we can always form a new statement from that, it is not the case that it is Tuesday. Slightly more naturally, it is not Tuesday. Okay, so this is the negation of a statement. So the negation of a statement P is denoted by this little tilde, this little squiggle P. Okay, so just squiggle P. Okay, when P is true, the negation of P is false. When P is false, the negation is true. That's all we're doing is flipping the truth value over. The negation is also sometimes denoted by this exclamation mark P or this little hinge symbol P. So P. Both of these are fairly standard notations that you might see out there, but we're not going to use them in this course. We're just going to use this first one, namely this squiggle P. Okay? We can summarize what this does and make some examples in this slide. So the negation of it is Tuesday is just it is not Tuesday. The negation of 4 is an element of A is 4 is not an element of A. So what we're doing here is just putting a stroke through that. Okay? Very, very simple. The negation of 4 is even is 4 is not even. Now if we think a little bit about this, well, 4 is an integer, integers are even or they're odd, so we could actually simplify this a bit further and write it as 4 is odd. Okay? And we can summarize what happens by negation in a truth table. Okay, so we'll use these a fair bit, at least when we get started playing around with basic bits of logic, to summarize what those things are doing. So in particular, if we have a statement P and it takes on the values true and false, we can look at what the negation of P, what not P looks like, in particular when P is true, not P is false. When P is false, not P is true. I've also added a third column here to say what's the negation of the negation. So a double negation of the original statement. Now in spoken English this is quite ambiguous and there's lots of cases where it's either true or it's false. But in mathematics it's actually very precise. In particular, the double negation of a statement P is just has the same truth values as the original statement. So if P is true, the double negation is true. P is false, the double negation is false. Okay. Also notice that the only truth values things can take on here are true and false. There's no third option. Also notice that P and not P, well, exactly one of them is true. Okay? This is called the law of the excluded middle. It can only be true or false. No third option allowed. Okay? Now, if we only play with negation, we can't get very far. Indeed, that's what that tells us. We can only sort of get back to ourselves. There's no other things we can do. We can't even combine statements. We're going to act on a single statement. So this is where the next 2 operations come in, namely and or, which are known in slightly more fancy language as conjunction and disjunction. So we can combine statements together using and or to make new statements. Now in mathematics and in logic, and or have very precise meanings, which they don't necessarily have in spoken English, and we'll come to some examples of that in a moment. In particular, if we let P and Q be statements, then the disjunction of P and Q is the new statement P or Q. And we know by P, this little sort of V symbol, this pointy triangle thing, Q. Okay, so this is very standard notation, so please use it. Don't write P little u Q. That's something from set theory. We don't want that. This should be a pointy sort of V-shaped thing. Okay? Now, P or Q, the disjunction here is true when at least one of P and Q is true. So it's only false when both P and Q are false. And we'll summarize that in a truth table in a moment to make it really very, very clear. Okay. Now, the other operation is called the conjunction of P and Q, which is just a fancy way of saying and. So the conjunction of P and Q is the new statement P and Q, and it's denoted in a very similar way to the disjunction, namely with this little triangle thing, but now the triangle's the other way up. Okay, so this is P, pointy triangle thing, Q, and this is P and Q. We read it as P and Q. It's the conjunction of P and Q. Now, P and Q is true when both P and Q are true and otherwise false. So this is only true when both parts P and Q are true. If one of them is false, the conjunction is false. Okay, now what you may have noticed here is the truth value of P or Q is quite different in spoken English. So it's one of the reasons that we're trying to make this very, very clear is that the colloquial, namely spoken use of the word or is often very different from this mathematical or. And we'll make that clear in the next slide or two. So let's make some examples. So let's take two statements. P says 8 is even, there's one statement, and Q says 15 is prime. Now we think about this guy's true, and this one's false because 15 is 3 times 5, not prime. But we can still stick them together using the conjunction and disjunction. So the disjunction, P or Q, is the new statement, 8 is even or 15 is prime. The conjunction, P and Q, is just 8 is even and 15 is prime. There's no weird stuff going on here. Okay? We're just sticking these things together with these connectors and an or, and those connectors do things to the truth values depending on what we're connecting. Now, if we look at this, the first one is true since at least one of these two is true. Because P is a true statement, P or Q is true. On the other hand, since Q is false, P and Q is false, because P and Q is only true when both are true. So let's summarize this in a table because that will be more clear. Okay, so we write down, well, now we have 4 possibilities, because 2 possibilities for P, 2 possibilities for Q, 2 times 2 is 4. Okay, so P is either true or false, and Q is true or false. So we make sure we get all 4 possibilities here. Okay, so when P and Q are both true, P or Q is true. P is true, Q is false, true. False, true, true. False or false, false. Okay, so P or Q is only false when both P and Q are false. P and Q, on the other hand, is only true when both P and Q are true. Okay? So it's very important that we memorize this truth table. We really have to understand this very, very clearly in order to do what we're going to do. Now, I just want to talk a little bit more about the word or, because it's quite different in mathematics than it is in spoken English. So the mathematical or is almost always an inclusive or. P or Q, this disjunction, P or Q is true when at least one of the statements P or Q is true. Okay, that's the one we just saw on the previous slide. But the colloquial or spoken or is often exclusive. P, and I'm going to write this as X or Q to distinguish it from the disjunction we learned just about. P exclusive or Q is true only when exactly one of the statements are true. Now, you've probably heard this on an aeroplane, for example, back when they used to feed us. Namely, the person would come around and ask you, would you like chicken or beef? Now, you're not going to get both chicken and beef, you're going to get one of chicken or beef. Okay, so we can summarize this in a truth table here, namely P or Q, we saw before, this is the line from before, P or Q is only false when both P and Q are false. But the exclusive or is only true when exactly one of P and Q is true. So P is true, Q is false, or false, X or true. Okay? So the exclusive or is quite different, and it does turn up from time to time in mathematics, and we have to make it very precise that that's what we're talking about. Okay? So usually when we see an or, we should think, okay, inclusive or, and when it's an exclusive or, we'll be very, very clear about it to make it very, very easy for the person reading what we're doing. So for the exclusive or, we might write exactly one of P or Q. Or we might write P or Q, but not both. Okay, to make it very, very clear to the person reading that we're talking about the exclusive or. Now, exclusive or is a bit of a special case. We typically will not see it. We'll almost always be doing with the usual mathematical or, which is the inclusive or. Okay, and that's where I'm going to stop.